Hi, we're going to do another example of combined stresses under combined loading. So you can see a structure over here, okay? And as I said before, you have to identify where the element is. So this is our element. So we can immediately locate our neutral axis. So this is our neutral axis. Okay, so this is the neutral axis. So from the neutral axis, okay, we've identified where our element is, so we can start sketching. So we're going to look at XY plane first. So we have our XY plane. So this will have rotation and a Z. Okay, so sketch this out. So what we're going to see is built in over here. Your structure. And from here, we have a load coming down. So this load is at 0.5 kilogram. Oh, sorry, kilonewton. We have an axial load coming in. So this is at 3 kilonewton. And then you have a load going here, 2.5 kilonewton. And we're going to identify where our neutral axis is relative to the element. So this is the neutral axis. And then we have our element H. Okay, so over here, this is our element H, which is of interest. So from here, we know that we have Px, because 3 kilonewton is acting into the neutral axis. So we have a Px, okay, so we can call this positive. So this is equal to 3 times 10 to the power 3 Newton. And you know it's going to induce on element H, okay, a minus. And on element H, is going to induce a compressive stress or maximum compressive stress. And then we're going to have moment about Z axis. So this will be 0.5, and the distance is this distance that I have to specify first. So it's this distance that is acting on relative to element H. Okay, so this distance is 0.15 meters. So we have 0.5 times 10 to the power 3 multiplied by 0.15. So what we have over here, so 0.15, 5 power 3 is equal to 75 Newton meter. It's rotating at this direction. So on element H, right, because we know that this is going to be our moment about Z, okay, so we know that it's going to induce tensile, right, tail end of the arrow, tensile, maximum tensile stress due to MZ, so maximum tensile stress. So from here, we also know that there's a shearing force Vy acting on the element. which is 0.5 times 10 to the power 3 Newton, and then it's coming down. Okay, so we have nothing else to analyze. Do not analyze the dot and the crosses. Okay, you have to look at another view. So next we are going to look into the other view on XZ plane. So we're going to view now. Okay, so this is our XZ plane. So this is rotation about y-axis. So we're going to sketch this out. So what we have, if you see, you have this feature over here, and then you have another feature that's coming over here. So that's from the plan view basically. Okay, so we have to sketch out the position of our neutral axis relative to the element H. Okay, so this is element H. Then we're going to put some loads. Okay, so we're going to have, what we see is we're going to have a cross over here, right? And this is 0.5 kilonewton. And then we have an axial load coming in, acting on the neutral axis, coming in, and it's acting at 3 kilonewton. Okay, we're having this at 3 kilonewton. Then you have another load coming in this direction, which we have not considered yet, and this is going at 2.5 times 10 to the power 3 Newton. So what we see over here, so we have dealt a lot with the 0.5 and 3 kilonewton already. It's a 2.5 that we're not dealt with yet. Okay, so over here, immediately you can identify V in the Z direction is equal to 2.5 times 10 to the power 3 Newton. And it's acting in this direction. Okay, and then we're going to take moment about y-axis. So it's going this way. Moment about y-axis is equal, so this distance now, so we have to identify this distance from here to here. So we have to know this distance. Looking at our, is also 0.15, right? So that distance is equal to 0.15 meters. So from here you have 2.5 times 10 to the power 3. Oh, yeah, yes, we're okay. Times 10 to the power 3. Oh, I do apologize. We have to write down here on element H. Okay, it's going to have the maximum shearing stress because it's at the neutral axis. Okay, now back to here. So 2.5 times 10 to the power 3 multiplied by 0.15. So this is 2.5 power 3 by 1.5 is 375 Newton. So we know that on element H, because it's on the neutral axis, okay, we know that bending stress will be equal to what? 0 by induced by 375. Because at the neutral axis on bending moment is equal to 0 stress. Okay, so that's all for the tutorial on stresses on combined loading. Thank you.